Here we go. 8-3. We have learned so far standard form of a quadratic. Can anybody tell me what standard form looks like? You don't need to write this down. You already have this in your notes. What is standard form? What? That's to find the axis of symmetry. What is standard form?
It would be like x2 and then x and then like a regular number.
Right, so like the general standard form is ax squared plus bx plus c, okay? Now Luke, if we were going to use that to find the axis of symmetry, what would we do? Negative b over 2a. So this was our axis of symmetry. This was standard form. You don't need to write that down. It's in your notes. Today, I'm going to give you a different form, but you're going to find some of the same things with it. So I need you to decipher between them. I need you to know which one is coming from standard form and what do you do there, and which one's coming from vertex form and what do you do there. They are different, but the same, okay? Take your time. If I miss something somewhere, if you're not getting it, just stop me and ask. So standard form is what I just wrote for you. Vertex form is this. Y equals A. That A is the same A as the other one. Okay? A. Then it's x minus h squared plus k. Okay? So your x and y are x and... I am recording, yes. Your x and y and your a are the same as they would be in standard form. But now you have this h and k. And you actually found h and k for me yesterday. 2 days ago. When did I see you? No, that was yesterday. What you're finding with your h and k is your vertex. Okay? Your hk is your vertex. Now I want you to see something here. The setup is x minus the h value. So when you see a number plugged in there, it looks like that number is a negative if that stays a minus, but it's actually a positive. You are subtracting whatever your h value is. If that's a plus, then your h value is actually a negative because it would be minus a negative of that number. And I'll explain that more as we do it, but I just want you to hear that. Maybe write this underneath. Your h value will be opposite of what it looks like. Your k value will be the same as what it looks like. So if your h looks negative, it's positive. If your k looks negative, it's negative, okay? One is opposite, one is the same. That'll make more sense as we go. Your axis of symmetry, just like it was yesterday, will be x equals. It's always x equals. X equals is representing a what? This is a line, okay? It'll be x equals, just like it was yesterday, it's the x value of your vertex. So it'll be x equals whatever that h number is. If none of this makes any sense to you yet, it's okay. I'm going to show you with numbers and it's going to make a lot more sense. All right, so given this equation, this is in vertex form, okay? These are in vertex form. If I want to find the axis of symmetry and the vertex, I actually think on these ones it's easier to just identify the vertex first and then write your axis of symmetry equation. But this will always be x equals every single time. So if you want to go through and write a bunch of x equals, go for it. Just so you don't forget to put x equals. Your vertex, okay? Remember what we said. Y equals A times x minus h squared plus k. That's your standard vertex form. That's a weird way to say it. It's not standard form. It's the regular vertex form. In that vertex form, we said this number would be opposite, and this number would be the same as what it looks like. Because right now I'm saying x minus my h value. X minus what gets you x plus 4? X minus a negative 4 would get you x plus 4, right? So if this looks positive, you make it the opposite of what it looks like, right, Shane?
Yeah.
Leave him alone. Take your notes. So the opposite of what this looks like right now, this looks like a positive 4. So it's actually a what? Negative 4. So your x value is negative 4. Your k value is what it looks like. What does this k look like right now? Negative 2. So that is a negative 2. Okay? So opposite when it's inside the parentheses attached to the x. The same when it's outside the parentheses, not attached to anything. So the axis of symmetry then is what? X equals negative 4. It's whatever your h value, whatever your x of your vertex is. Look at the second one. Okay, this is vertex form. Y equals a times x minus h squared plus k. What is your h value right now? A positive 3. Opposite of what it looks like. Right now it looks like a negative 3. But the formula says x minus some number. So I'm subtracting a positive 3. So my vertex is going to be 3. What's your k value? What are you adding? You're adding 0. There's nothing there. So your vertex is going to be 3, 0. So what's your axis of symmetry? X equals 3. Don't forget the x equals, right? X equals 3. How's this going? It's okay? Okay, this one. Here's your standard form. Your vertex, remember, is opposite and the same. What's your vertex? Positive 5, negative 4. Opposite of what it looks like here. So it looks like a negative 5. That means it's a positive 5. This looks like a negative 4, so it is a negative 4. Okay, opposite of what it looks like, the same as what it looks like. So what's your axis of symmetry? Not just 5. X equals 5 is your axis of symmetry. Axis of symmetry is always the x value of your vertex. Okay, this one's tricky. That's okay. Do you want to keep, go ahead. I'm not in a hurry. Or do you want me to explain something? Number 4 looks goofy. You could say this one is in standard form. If you treat this like standard form, y equals negative 2x squared plus 0x plus 3, right? That's standard form where this is a 0. But you could also treat this like vertex form. If we treat it like vertex form, this is still your a. What happens is it's kind of like this. Y equals negative 2 times x minus something squared. What would that something be? If it's just going to be x squared, I have to subtract 0, right? And then plus 3. So if we're going to look at it in vertex form, it would look like this. What is your vertex on this problem? 0, positive or negative 3? Positive 3. Exactly what it looks like. Okay? So what's your axis of symmetry? X equals 0. Just remember, an axis of symmetry, when it's x equals 0, that's always the y-axis, right? This would be your axis of symmetry on that one. Whenever it's 0, it's the y-axis. Any questions on that? Okay, so here's what we're going to do. We're going to apply that. It says graph this using a table of value, identify the axis of symmetry, the vertex, the domain, and range. So very similar to yesterday in this regard, but we're coming about it a different way. We're coming at it from vertex form instead. So take a look at this setup. And we're going to start here. I like from vertex form, I think it's easiest to start at the vertex. What would this vertex be? Opposite of this, the same as that. So negative 2, positive 7. Where does that go in my T-chart, Khalees? In the middle. What did you say?
Okay, so what have we been doing the past 2 days?
Standard form. That's when it looks like this. When it's in this format to start, that's called standard form. Now this is starting in vertex form, which looks like this instead.
So are these 3 forms only for quadratic?
Just for quadratics.
Okay.
Yep. Yeah.
Are these 2 like, are they the same like numbers but like in different forms?
Yeah. It's essentially like you could do it in standard form or you could do it in vertex form. It just depends what you're given. Okay. So your vertex goes in the middle. What's your axis of symmetry? X equals, and then whatever your x value of your vertex is. Okay? If we're going to plot 5 different points, I said this yesterday. I don't know if you did it this way yesterday, but I'll say it again today. You don't have to check all 5. It's not a terrible idea to check all 5 just to make sure you did these ones right, and therefore these ones are right too. But they reflect, right? This is always going to be the middle. So if I'm going to go numbers below -2, it would be -3 and -4, which are maybe not lovely to work with. If I go the other way, it's -1 and 0. Those are a little more lovely to work with if you ask me. I would plug those in, and then your y's on the other side should be the same numbers. They'll reflect, okay? They'll be the same setup. So if we're going to plug a -1 in, this is the opposite of -1 plus 2 squared plus 7. That'll be your y value. Okay, I'm plugging this -1 in to see what my y equals. So -1 plus 2 is what? Or you could plug this whole thing into your calculator exactly how you see it. But I'm going to mental math it with you right now. What is this? -1 plus 2? 1. So this is the opposite of 1 squared plus 7. Do you square or take the opposite right now? Square, because this is essentially multiplying by a -1. Okay, so 1 squared is 1, make it the opposite, so -1 plus 7 is 6. So when you plug in a -1, you get a 6. What does that mean? What other number will have a 6 with it? The -3, the one that would be the mirror of it when we set up our graph. Okay, what if we plug in a 0? The opposite of 0 plus 2 squared plus 7. Again, plug it into your calculator how you see it, or do the mental math. 2 squared is 4, so the opposite of 4 plus 7 is what? 3. That means this one also is a 3. Okay, so now let's plot what we know. A vertex of -2, 1, 2, 3, 4, 5, 6, 7 puts us there. That's my vertex. Then I have -1, 6. And -3, 6. That's those two. Then I have 0, 3. And I reflect that. Maybe you want to draw your axis of symmetry in. That kind of helps you with reflecting things. If I'm 2 to the right here, I need to go 2 to the left for my -4, 3. So here's my graph. Looks just like yesterday. Okay, it's just we came at it from vertex form instead of standard form. What's your domain? Good job. All real numbers. And then the range. The range is a little bit trickier. The domain is always all real numbers. That will not change with what we're doing, okay? The range will change. It's always going to be a y, but it might be greater than or equal to, or it might be less than or equal to. What's this going to be? When it goes down, it's less than, okay? So when it's opening down, less than or equal to what number? Always the y value of your vertex, right? That's the highest y value, so it's everything less than or equal to that. Khalees. I do 2 parallel lines, and then I make that far left one an R, is what I do. Okay? Yours looks what? That's okay. As long as I know what it is, it doesn't need to be perfect. Questions on that? Okay. Let's do one more, and then I have another little something to tell you about it all. Take a look at this vertex form. What's missing from vertex form here? The K. What are you adding to the end of this? 0. If there's nothing there, make it a 0. Okay? That means our vertex is what? Positive 1, 0. Okay? Notice this. That 3 is not doing anything for us right now. It is. It's just we're not working with it yet. But it is doing something. Okay? You don't need to worry about it right now. We'll get there eventually. What's your axis of symmetry? X equals 1. Okay, so I'm just going to plot those right now, just in case some of you like to do it in a different order. X equals 1 is this. Right, it's where your X value is always 1. Your vertex is 1, 0. That goes here, and that's in the middle, 1, 0. If we're working our way around those numbers, then this would be 0 and -1. This would be 2 and 3. Do you want to plug in -1 and 0 or 2 and 3? 2 and 3. Okay, so this is going to be y equals 3 times 2 minus 1 squared. Again, you may plug that into your calculator exactly like that if you want, or you can do the mental math. 1 squared is 1 times 3 is 3. So when you plug in a 2, you get a 3. Where else does that 3 go? With the 0, right? The opposite side of that. Okay, then plug in a 3. Y equals 3 times 3 minus 1 squared. So 2 squared is 4 times 3 is 12. So you get a 12 and a 12. When they fall off the graph like this one does, I don't make you graph that last one. If you want to do a few extra lines, if it's like barely off, go for it. But if it's way off, just give me the first 3. So 0, 3. 1, 2, 3, and reflect that. And then 3, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you don't have to plot those if you don't want. I would just do these 3 and call it good. What's the domain? All real numbers. And then your range, when it opens up, is that greater than or equal to or less than or equal to? Greater than or equal to. Your y values will be higher than what number? Than the y value of your vertex, which is 0. Questions on that? Feels very familiar, right? You just have to start by finding the vertex instead of by finding the axis of symmetry. Okay? Okay. So there are transformations. This is why vertex form is super nice for this reason that we're going to do right now. Okay? You with me? Okay. Yeah, Khalid. Take the service leadership class. When is it? I mean, most people take it their junior or senior year, or both. I don't think you can take it as I know someone took it as a sophomore. I don't think very many people take it as a sophomore. Are any of you taking it next year? No. It wasn't? Yeah, I think it's a junior or senior class. I know there was an exception one time. Okay. This next part is what I talked to you about yesterday at one point. Remember I said this is called the parent function? Psst. Hang out with me. The parent function is just like the simplest version of a function. Okay, the parent function. So your parent function for any quadratic is this. And I think I told you that yesterday. That is known as the parent function. And then from that, so if you think of it like your parents, right? You came from your mom and dad, and you have some of their traits, but then you have changed from who they are. Right? You're not identical to them. So you're like the kid version of your parents put together. So that's what's going to happen here. A transformation is going to be a change to the size or the position of your quadratic. Okay, so it's either going to change in size, as in it's going to like broaden or narrow, or it's going to shift to a whole new place. Okay. So I'm going to show you how we can tell what these do. But in order to show you, I'm going to graph this first to compare it. Okay. So this is the parent. That's what this, I'm making it blue now. Their black version. Okay. That's the parent function. This function is no longer the parent. This is the parent, okay? What happened was this shifted somewhere. So we're going to plug in some numbers to see where this one shifted. Can you tell me the vertex of this one? -2. What? 0. It's like there's a +0 back here. So -2, 0 is your vertex. -2, 0. Okay. If we were to plot 4 more points, I would plug in a -1 and a 0, or a -3 and a -4. If I plug in -1, it's y equals -1 plus 2 squared. So 1 squared is 1. That means that one's a 1 also. If I plug in a 0, y equals 0 plus 2 squared. 2 squared is 4. That means this one is a 4 also. If you graph that, you have -1, 1, and 0, 4. 1, 2, 3, 4. If I reflect those, it ends up looking like this. Tell me what happened to the parent. What happened to that blue to become the pink? How did it move or grow or shrink, or what happened?
Negative.
It moved to where? To the left, okay? The transformation that happened here is it moved left 2 units. Look at this. X plus 2 squared. Remember what we said? This is opposite of what you would expect. So plus 2, think of it as minus 2. Minus 2 would be 2 to the left for your x's. Okay? So when it's inside, maybe you want to write this over here. Inside the parentheses is going to move left and right. Outside the parentheses, so parentheses squared and something ends up out here, that's going to move up and down. Okay? Let me show you that. If we graph this number 8,
If it was a negative, it would move to the right.
if this was like this, right?
It would move to the right.
That's going to move to the right 4, but it's also going to move 1 up. Let me show you. So x squared plus 5. If I'm going to find, right now my vertex is 0, 0. My new vertex is going to be what? This is like x minus h squared plus k. What is this number here? X minus what would get you x squared? 0, right? That's a 0. This is a 5. So 0, 5, 1, 2, 3, 4, 5 is right here. What happened to that vertex? It went up 5 units, okay? So the transformation that happens here is it goes up 5. Now, you can plot a 1 and a 2, a -1 and a -2 to see that. So if I plug in a 1, 1 squared plus 5 is 6. So those will both be 6. If I plug in a 2, 2 squared plus 5 is 4 plus 5, so 9 and 9. If you graph that, 1, 6, negative 1, 6, 7, 8, 9, 7, 8, 9. Your graph moved up 5 units. Well, look at what it started as. Y equals x squared plus 5. That means up 5. If it's outside of the parentheses, I didn't mean to do that. Bummer. When it is outside the parentheses, that's going to move up and down. When it's inside the parentheses, it's going to move left and right, but opposite of what you would expect. Shane, I would love to not see the back of your head anymore. Okay, so without even graphing these, tell me what this one is going to do. Remember, this is going to go left and right. This is going to go up and down. Left or right? Opposite of what you would expect. It's going to be left 1. Because a positive, we would normally think we go right 1, right? This is left 1. Where does this go? Down 6. Okay, so inside is opposite, outside is the same. Just like we said for finding the vertex. Okay, this one. Do you know what's going to happen when the A value out in front is negative? It doesn't stay the same. It flips it, okay? So this is going to be upside down. It's going to flip it over because of that. It's also going to shift. Negative 4 is going to send it 4 units where? To the right 4. And then plus 1 is going to send it where? Up 1. God bless you. Does that make sense? You want to do this one for me? You're not listening to a thing I'm saying right now. Help me with this one, Shane. Where's this going to move?
What?
Where is this one?
Gonna move
Yeah. What's a minus 3 going to move it to?
up 3.
No. You should pay attention. Where's a minus 3 going to move it? This is going to move it. So we would think left. Opposite. This is going to be to the right 3. Where's this one going to move it? This would be down 2. Okay. You're actually not going to have to do any of the negative stuff yet. I moved into what we're going to do. We're going to keep working from this on Monday. So that's the extent of what you need to be able